Americans spent thousands of dollars building air conditioning systems into their homes without realizing they were dismantling something far more ingenious that had already been built into older houses for generations. What if I told you that there's a cooling system still standing on millions of American homes right now, completely invisible to most people, and it was so effective that entire regions of the country were designed around it before electricity even became common? The answer isn't hiding in some complicated mechanical setup or forgotten patent office filing. It's literally above your head every time you step onto an old porch. And once you understand what was happening up there, you'll never look at vintage American architecture the same way again. Picture this. It's 1895, July, the middle of a brutal heat wave crushing the southeast. There's no electric fan in the house, no ice delivery coming today, no way to make cold air appear from nowhere. The thermometer on the outside wall reads somewhere around 98 degrees, but inside the house, it feels like 110. So what do families do? They don't suffer helplessly. They don't sit inside waiting for evening. They don't even seem particularly distressed in the historical photographs from that era. Instead, they gather on the porch. And here's the thing nobody talks about. The porch isn't just a place to sit. It's actually a piece of climate engineering disguised as casual outdoor space. The real secret starts with understanding what's happening directly above their heads. Most modern people look at an old porch ceiling and see nothing. It's just wood, just a finished surface, just the underside of a roof. But the original builders understood something fundamental that we've completely forgotten. That ceiling and everything around it wasn't decoration. It was part of a precisely designed system that made summer actually survivable without burning through money on mechanical cooling. Let me explain how this worked, because once you understand the mechanics, you'll realize something shocking. We've been spending enormous amounts of money on machines to do what good architecture used to do for free. The problem these old homes were solving was devastatingly simple but brutally relentless. The sun doesn't care about your comfort. It hits that roof every single day with about 1,000 watts of energy per square meter. That energy has to go somewhere. If you're the roof, that energy becomes heat. Tremendous, accumulating heat that slowly penetrates downward through the roof structure, through the attic, and eventually into the rooms below. Now imagine that the entire upper surface of your house is becoming a heat conductor. You can literally watch it happen in thermal imaging. As the sun moves across the roof throughout the day, different parts of the house gradually begin to radiate that absorbed energy back down into the living spaces. The ceilings and bedrooms become warm. The plaster walls start releasing stored heat hours after sunset. And by evening, the interior of the house is still baking even though the sun disappeared 8 hours ago. This is where the original porch design solved something nobody really understood as climate engineering back then. They just knew it worked. The porch wasn't built randomly. It was built as a deliberate buffer. Imagine stepping from scorching direct sunlight into shade. Your body feels cooler almost instantly, even though the air temperature hasn't actually changed. The sun's radiant heat is no longer striking you directly. That's exactly what a porch roof does to the exterior walls of a house. It blocks the direct radiation. Those exterior walls that face the porch side, they're not absorbing the sun's direct energy anymore. They're sitting in shade. And when the walls don't absorb that energy, they don't heat up. And when they don't heat up, they don't transfer that heat into the rooms behind them. But here's where the design gets genuinely clever. The high ceiling wasn't just about aesthetics or some old-fashioned preference for spaciousness. It was about physics. Hot air rises. When the porch fills with morning sunlight, and remember, the porch is shaded from the brutal afternoon sun but still gets plenty of light and ambient heat, that air warms up. The air beneath that high ceiling becomes less dense and begins rising. But here's the critical part. The porch isn't a sealed room. It's designed to be open on the sides. That hot air rising toward the ceiling has an exit path. It escapes outward into the open air. Meanwhile, cooler ambient air can circulate in from the sides underneath the shade structure. You've essentially created a natural convection system without any electricity, without any moving parts, without any sound, just the physics of heat and the movement of air doing the work that modern air conditioning requires a compressor, refrigerant, and megawatts of power to accomplish. Here's the overlooked part. The old system was more energy efficient in every way that matters. Zero electricity, zero fuel, zero maintenance costs, completely passive and completely effective. The modern system uses electricity constantly during warm months. It requires regular maintenance. The compressors burn out and need replacement. The refrigerant costs money. It requires climate control equipment to be installed, maintained, and eventually disposed of. And it only works as long as you're paying for electricity to run it. Generations of builders and architects designed buildings that would be comfortable indefinitely without any energy input at all. We replaced that with systems that require constant energy expenditure. From a thermodynamic perspective, it's actually a step backward. But here's the fascinating part. It isn't gone. These systems still exist, If you drive through older neighborhoods in cities like Savannah, Charleston, New Orleans, or any of the old textile towns across the Southeast, you still see these homes with their deep porches and surprisingly high ceilings. Many of them still cool themselves to some degree using these original methods, even though most modern homeowners don't understand that's what's happening. The porch isn't air conditioning, but it's noticeably cooler than the open sun. The high ceiling provides relief that low ceilings don't. The shade structure still does its job. The architecture is still cooling the space, still protecting the interior walls from direct radiation, still allowing heat to escape. The measurements prove it, if you actually look. Thermal imaging studies on old porches show clear temperature differences between shaded and exposed areas. Wind flow studies show how open-sided designs create natural ventilation patterns that mechanically cooled modern homes can't replicate. Occupancy records from the era before air conditioning show that summer heat waves, while uncomfortable, were not the crisis we've been led to believe. People adapted, people used design, people understood their environment, and their buildings reflected that understanding in ways we've almost entirely lost. If you wanted to reconstruct this system in a modern context, you could. Build a porch with a high ceiling, 12 feet minimum, higher if possible. Make sure it's open on at least 3 sides, with minimal solid walls. Extend the roof overhang far, enough that it shades the adjacent windows and walls during peak sun hours. Position it to catch prevailing breezes. Make sure there's a clear pathway for hot air to rise and escape. Coordinate it with interior door and window placement. And then, observe what happens. You'll immediately notice a difference compared to sitting in direct sunlight. The temperature difference isn't enormous, but it's real. The comfort difference is significant. This is the secret that's been sitting above our heads on millions of American homes, completely invisible to people who've stopped understanding architecture as climate control. What looks like a decorative porch, a nice place to sit, a charming feature, is actually precision engineering from an era when engineers were still designing buildings, not just installing machines inside buildings. The next time you visit an old house, do something most people don't do anymore. Look up at that porch ceiling, really look at it, notice the height, notice the materials, often wood designed to allow heat to pass through without trapping it. Notice how far the roof extends beyond the walls. Notice where the openings are. Notice which walls are shadowed during different times of day. Notice where the windows face. These aren't random choices. These are the architectural decisions of people who understood heat, understood air movement, understood the path of the sun, and had no choice but to build that understanding into the structure itself. That's what Secret Vault is really about, finding the knowledge that's still sitting in plain sight. The solutions that our culture dismissed as old-fashioned without understanding what we were dismissing. The engineering, hiding inside buildings from an era before climate control became a machine you could buy. Because the truth is, some of the most advanced climate engineering ever designed isn't in a modern building at all. It's on the porches of homes that were built 150 years ago. It requires no electricity, no compressor, no maintenance, no ongoing cost. It works through pure physics and remains effective indefinitely. We replaced it with convenience, not with something smarter. So the next time someone talks about old houses as inefficient or old-fashioned, remember that porch ceiling. Remember what it was designed to do. Remember that the people who built it understood something we've forgotten. And remember that sometimes the most forgotten solutions are sitting directly above our heads, waiting for someone to finally look up and remember why they were built in the first place.